All right, hello everybody. We're doing AP Statistics here, and we are doing a one proportion z-test today. We have our problem here. Suppose the proportion of men with nearsightedness is 18%. A study found that in a simple random sample of 182 women, only 16% were nearsighted. Perform a test of significance, that means a hypothesis test, to determine if women are less likely to be nearsighted than men. At the alpha level of 0.04, so that's not normally in the problem. That changes my level, where if it's lower than 0.04, then I'm going to reject it. Okay, where normally if it was lower than 0.05, I would reject it. Okay, so, all right. Okay, notice that the 18% here is a population parameter. That's known fact for all men. So we know that about men. That's the population parameter. And then we took a statistic here. 16% is a statistic, or p hat in this case, all right, for the women. All right, let's get going. Okay, step one is our test name, hypothesis, and defining the parameter. Our test name is a one proportion z-test. I want you to notice that it's a proportion problem. It's not a mean problem. I did not tell you the standard deviation. And a proportion is 18%. That's 18% out of 100, right? Okay, and so I know automatically in a one proportion z-test that my hypothesis is going to be p, the parameter again, equals some number, and whatever that number is goes there. Okay, and I just change the sign there. In this case, the proportion of people that are nearsighted, it said was 0.18. That was the fact that we know. Okay, and that'll be 0.18 there, and I need to put that sign in there. All right. We are thinking that it says, let's see, if women are less likely to be nearsighted. If women are less likely to be nearsighted, then they would have less of a percentage or probability of being nearsighted. The probability of a woman being nearsighted would be less than 18%. Okay? Define P. P is the true proportion, again, not a p hat or from a sample. The true proportion of nearsighted women, that's what we're looking at. If nothing special is going on, it should be 18% like the men. Okay, but if we discover something unusual, if our findings were significant, we might discover that women have a lower percentage of, or less likely to being nearsighted. That would be something interesting we found out. Okay? All right, step two, conditions. Random sample. Okay, in our problem, I believe it says, let's see, in a SRS, simple random sample right there. So all I have to do is put a check. Okay, for independence, 182 women are less than 10% of all women. And finally, nearly normal. Okay, this is not a mean problem where n must be greater or equal to 30. This is a proportion, so n times p and n times q must be greater or equal to 10. And the p we're going to use is the hypothesis, the 18%, because remember, we're operating under the assumption that the null hypothesis is true. So if that's true, the real proportion of women having nearsightedness is 18%. So again, if that's true, that would be what I'd use here to check for nearly normal. Okay, so n times p, I have 182 women, again, not p hat, p from your hypothesis, times 0.18, we'll get that value, and then I'm going to have to do n times q. If 18% are nearsighted, that would mean 82% would not be. Okay, and we want both those values to be greater than 10, which it will be. Okay, 0.18 times 182 gets me 32.7. I'm going to round that, say it's 33. All right, and then I have the rest will be here, 182 times 0.82. And that'll be 149.24, and I'll round that to 149. If you notice, both those will add up to the total of 182, but both are greater or equal to 10. That's my condition for nearly normal on a proportion. All right, let's get down to our calculation, step 3. First thing we have to do is find our standard deviation. Okay, it's not the standard error here, it's standard deviation because we know p, we're operating as if p is 18%. Okay, that's the true proportion of men. We're assuming it's the same for the women. Okay, so that's going to be 0.18 times 0.82 over my sample size of 182 women, and I want to square root that whole package there. Let's get that value for you. Okay, I want to do the square root of 0.18 times 0.82 divided by 182. That gets me a standard deviation for this group of 182 of 0.0285. Okay, and in reality, we're real far down the road here. Okay, in our picture, our true picture should be that the proportion is 0.18, and if I have a group of 182, I would get a standard deviation of 0.0285. That's my picture, okay? And then we found 16%, and we want to know the likelihood that if it was really 18% with that standard deviation, how likely is it that I could get a sample of 182 women, okay, which determined that standard deviation, and have the answer be 16% or less? That's on the left here. So I want to know the likelihood that we would get a result out there. Okay, that'll help me write my problem, but I'm going to calculate my z-score first. Okay, my z-score is what I got in my problem here, 0.16 minus what the average is supposed to be, 0.18 divided by the standard deviation of 0.0285. That z-score, let's get that. Looks like 0.7018. And a z-score went around the two places, 0.70. Okay, now we know the z-score stands for how many standard deviations above or below. By the way, this is negative. Okay, that's important to know because it tells us that we're below. And we know from our empirical rule that anything outside of 2 standard deviations would be considered unusual and unlikely. This is only lower by 0.7, 70% of 1 standard deviation, so it shouldn't be a highly unlikely event. Okay? All right, so in our problem, I'm asking you the probability that your sample, not the real p, because we know the p is 18%. What's the probability your sample, though, if that was true, would be less than or equal to 0.16. It doesn't matter if you write the equal sign or not. They count both the same in statistics. All right, and then I'm going to write this as my z problem. If I transfer it to a z distribution, that would be equivalent to the probability that z is less than or equal to negative 0.7. All right, we're going to get our test and get our p-value now. All right, so here we go on my calculator. Go to Stat, tab to Test over there, and we're going to do a 1 proportion z-test, which is choice number 5. All right, my p with a 0, that's your null hypothesis, 0.18. Okay, what did we find? Okay, well, I don't actually know how many we got. We got 16% of 182, so I'm going to multiply in the x spot 0.16 times 182, and that says it's 29.12. That will give me an error. It has to be a whole number. Remember, I checked 182 people. They were either nearsighted or not. I didn't get 0.12 of another person, okay? What happened is when they tell me I got 16%, that's not really accurate. That's where the error is, okay? So round it like normal. So 0.12, excuse me, I'm going to put in 29 for that. So we found 29 out of 182, and our hypothesis is less than. We think the true proportion might be less than the null. It should match your hypothesis right there. All right, I'm going to hit enter. Okay, and it says I have a p-value. I want you to notice it says that my z is negative 0.725. Okay, it's slightly off because of the rounding that we do in there. Okay, but the p-value is 0.2341. All right, our alpha level, normally 0.05, but they said to check it at the 0.04 level, okay? Now, again, if the p-value is low, reject the hoe. That p-value is 23%. It's much higher than 4% or the normal 5% if it would have been that. Okay, so our p-value is high, it is not low. We are not going to reject the hoe. We do not have enough evidence to say that that would be highly unusual of an occurrence. What we're saying is if we took this sample and checked for nearsighted women, we could get a result as extreme or more than we did 23% of the time, which is quite a bit. That's like 1 out of every 5, a little more than that, right? Comes our conclusion again. So again, our p-value is low, we reject the hoe. No, ours is high, we do not. We fail to reject it. With a p-value of 0.2341 and an alpha level of 0.04, we do not have sufficient evidence to reject the null hypothesis that the true proportion of nearsighted women is 18%. Okay? And then I'm going to double check here, because if they ask a question, I got to make sure and answer that question. Okay, it says we're supposed to determine if women are less likely to be nearsighted than men. Okay, and I would add on to that that we cannot say that women are less likely to be nearsighted than men as a result of our findings. Thank you.